Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Tobias. Hi, Tobias. Tell us a few words about yourself and about the tool you want to show us.
Yeah, hi, Alexei. Thanks for having me. My name is Tobias. I'm the CEO at Mostly AI. We are a company that is working in the space of synthetic data. And actually, earlier this year, we released a fully open source package to create synthetic data, our Synthetic Data SDK.
Okay, do you want to show us the demo?
Absolutely. Let's get into it. Let me share my screen. All right.
So this is where we give you the star, right? So this is the repo.
Exactly. This is
Mostly.
where everyone can give us a star. So github.com/mostlyai/mostlyai. That's the repo of the Synthetic Data SDK actually. And yeah, it's actually also a good place just to get started basically. So we provide a couple of links here and a couple of good quick starters. So overview, the most important primitives. There's a short video if you want to check it out, some features of the product, and then how you can get started very quickly. Also some performance benchmarks here for the ones that are interested, and some of the more details. But we can maybe look at this actually in action. So I have here a notebook. So there are two ways of basically installing the SDK. One is what we call the local mode, and the other is the remote mode. I'm going to demo here the local mode, which means basically everything happens within the Python environment. Right, so no data ever leaves the Python environment, no data is uploaded anywhere. And I'll talk about what synthetic data is and all of that, because maybe some of you will wonder, okay, what actually is it? But I always like to show it really hands-on. So pip install, Mostly local, of course, already did this, so this is all satisfied here. The latest version we have at the moment is 4.70, but we release quite frequently, so almost every week, sometimes even multiple times a week. What you then do is you initiate the SDK and then here the client running in local mode. So that's important here. So local equals true. That means now everything is going to run in local mode. And so what the SDK actually does, it allows you to take an existing tabular data set and to turn it into a synthetic version of that data set. And the synthetic data will look and feel like the original data. It will contain the same statistical properties, but with one big difference, it will not contain any personal identifiable information. So effectively anonymizing the data. And we're going to see how that works. So
in this case, we kind of throw, so the use case would be we take the data set we have, we generate synthetic one, we keep the original one private. Let's say if we want to publish a data set, then we release the private or the synthesized one.
Correct. Right. So yeah, so everywhere where data privacy is a challenge to make data accessible, you can use synthetic data as an alternative. It can be, of course, external data sharing, for example, if you want to share some data with some partners, external, research, universities, and things like this. But also internally, we certainly see this with many large organizations, especially the very large enterprise organizations, that even internally, you typically don't give access to data to everyone. And so with synthetic data, you could give many, many more people access to data. All right, so we now have the client initialized. Again, it's in local mode, which shows me here that everything is actually going to run here now on my MacBook with, I have 16 gigabytes of RAM, 10 CPUs, and 0 GPUs. That's also important, actually. So for tabular data, you don't need GPUs. The SDK comes with a model architecture that's called tabular argin. And it's a highly optimized model architecture that we actually developed, and we also open sourced earlier this year for tabular data. If you want to work with text data, then GPUs are highly recommended because otherwise it's going to be very slow. But for tabular data, that's totally fine. So let me actually just load some tabular data in here from a public demo repo. It's census data, so from US Census. It's social demographical data, right? So it's about, 48,000 rows of data, 15 columns. And things like age, work class, education, marital status, and so forth. It's a very, very popular data set. Many of you, I'm sure, will have seen this. And so this I will use now as my input data in order to create a synthetic version. And the way I need to do this is in two steps. The first step is creating what we call a generator. A generator basically wraps the model weights of the trained model plus some metadata. And that's then the asset we're going to use to actually create synthetic data. So The primitive is mostly .train, and then I can provide, of course, the data as an input. So that's going to what I'm doing here, data. So that's going to be the data frame here. And we do require pandas data frames as input. And then there's lots of things I can configure if I want to, but I don't have to. So in here, what I'm doing, I'm just basically saying setting the maximum training time to 1. Many other things can be configured. And if you want to see all the details, then we have here our usage examples. So if you go here into usage examples, it's a good way to get more into the details of how you can actually configure, for example, your generator. So what's now happening here locally on my machine is the data is being analyzed. It's then encoded, and then the training of our generative model is taking place. So this is really where now the SDK is feeding that input data, that census data, into the model architecture. So there's no pre-trained model architecture or anything, but everything, all the raw data is fed into it. And we see here the epochs as they develop. The model tries to learn as much as possible about the input data. All the statistical properties like correlations of variables, distributions, but it's only learning generalizations, right? The goal is not to learn anything by heart, but the goal is to really learn just a representation of the original data and then use that to create a synthetic data. And of course, we don't want to overfit, right? We also want to protect the privacy of individuals in that original data set. And so there's, of course, overfitting prevention built in, but there are also some more advanced features around privacy protection. For example, we take care, or the SDK takes care of what we call extreme values, rare categories. So things like that, value protection we have in place. So you can really be sure that the data you're creating is going to be anonymous and doesn't contain any personal information. So this is now here, or was completed after 1 minute, right? 1 minute here, because that's what I defined as a maximum training time. With larger data sets, this can actually take quite some time, right? So this can go up to the hour, into hours. A small data set like this with 50,000 rows and 15 variables or so, 1 minute will give you a good start. You can, of course, then always, redo this and increase the training time to create more higher quality synthetic data. So in principle, the more training time, right, the more the model has to learn, and then the higher the quality. All right, so that is completed. Now what also happened is a small synthetic data set was already created in order to now create what we call a model report. And that's what we're going to see next here. So we're going to say G reports display true. That is now pulling up actually a quick analysis of the synthetic data we just created. And it compares the synthetic data to a whole lot data set to see actually how well did the generator learn the representation of the original data. So we see here an accuracy 95.6%. That already gives me a first indication of how good that generator is. That's based on certain statistics, certain characteristics, so univariate, bivariate, and trivariate distributions. We also have some more distance-based metrics and similarity-based metrics.
What are these things in the parentheses? So I see AUC is like 60% and then 50 is in parentheses.
Yeah, that is in comparison to a holdout data set. So actually comparing the original data to a holdout data set itself. So for example, here, when you look at the 98.5 here accuracy, that is kind of like the maximum accuracy that you could expect. Even if you compare original data with itself, you don't get 100% accuracy, but 98.5 is kind of like what you can expect. So 95.6, it's already pretty good.
Mm-hmm.
So a couple of things here where we compare original data in gray here with the synthetic data that's here in green. You see here the differences on the correlation matrices. And then here, interestingly, the univariate distributions. So for every variable that we had, remember, we had 15 different, right? We see here the distribution of the original data. So let's look at age, for example, in gray. And then we see the distribution of the synthetic data in green. And just by looking at this, we can see, yes, it matches very, very closely. We have a very good representation of the original data. And I didn't specify anything, right? So the model learned all of this by itself. And we can just, really trust now that, yes, this synthetic data represents the original data. But it's not only about independent, let's say, univariate distributions, but it's also about correlations across variables, right? So the bivariate distributions we also plot. And you see here, for example, there's a clear relationship between education and education. That's basically just a, a numerical representation of the education level. And it's very clear here that that's what's in the original data, but it's also true in the synthetic data, right? So the model learned also these correlations, these patterns, and is then able to reproduce synthetic data of high accuracy. So there's more to that. I can download this as an HTML file. I can share this with others. But this is a first quick glance for me, a first quick way for me to check, okay, is the data good? And so, yeah, typically 95%
like
plus.
a good way to do, it looks like a good way to do exploratory data analysis too, right? Not only to generate data, but also the report that you show is fairly decent, right? It's pretty good. Like, let's say if I wanted to do exploratory data analysis, I would spend a lot of time building a report like that. And here I just get it after 1 minute of training. It's really cool.
That is actually true, yeah. So it also gives you a first, view at the data, and yeah, some people actually use it also for that. Yeah, and you get it out of the box. That is also available as a separate project, also Apache v2 license, fully open source. If I actually don't want to create such a model report, as we call it, I can run also the train primitive with enable model report false. So because it takes a little bit of compute, right, to create all those charts and everything. If I don't want that, if I feel already happy with what I have, then I can run it like this. So now once I have this train generator, and remember it's we defined it as G. I can use that to sample from the generator, and that basically means I will just create synthetic data. So here I'm defining 100,000 rows of data, but I could do any arbitrary number. So if once I have a trained generator, I can create, let's say maybe I only want 100 rows of data, and then yes, I get 100 rows very quickly. I can say I want 10,000 rows of data. I get it very quickly. I can do 100,000, and that's also very quickly. Oops. And probably once I then get into the millions or so, it will take a little longer. But in essence, just then probing that's the train generator. And now actually just looking at this, this is now already synthetic data, right? Just looking at this, it looks like the original data, right? If you compare this to the data frame that we had before, right? The structure is identical, of course, all the variables are still there. But also what we see actually for the variables itself, age, yes, they're numerics, all of that is still there. And so that's the beauty of synthetic data. When done well, it really looks and feels and has the same properties as the original data. But the big difference is now these individuals here in that data sets, they existed in the real world, right? This person actually, was 38 at the time of the census and was divorced and all of this. However, this synthetic data, these are all made up. These individuals did not exist. And that's why you get a very strong privacy guarantee when using synthetic data. All right, so that is kind of the happy path of creating synthetic data, trying to recreate what I had originally as closely as possible. What I can also do, though, and I want to show this now next, is to actually modify the data a little bit. Modify the data during the synthetic generation process. And so what I'm going to do is I'm actually going to provide here for what we call seeded generation, a seed data frame where I define characteristics of the data set or of the synthetic data set that I want to have. So here I will define, I want, and this is now the seed data frame that I have, again, 48,000 rows of data, but I'm fixing basically two attributes. I'm defining age should only be 35. So I only want 35-year-olds. And the split between male and female, I'm creating here with this function here, a 50-50 split, right? So I want 50% males, 50% females. And so if I now look at this, yes, 50-50 in my seed data set, that's great. And now I'm going to use that with the mostly generate primitive here. I will select the generator G that I just created, and I will use this seed as an input. So let's do that. And let's see what the data will look like. So this again is now the function call to actually create synthetic data. Again, I can define more things. I can how much data I want, all those kind of things. And again, all the examples here, and also in the documentation. Also, we have a quite extensive API reference. So for all the details here, it's all in the docs. All right, so now let's look at the data that we just created. We have, what do we have? Let's calculate here our share. So in the training data, in the original data, right, we had a share of 67% males and 33% females. In the synthetic data, because we defined that in that seed data frame, we now have 50-50. And that's exactly what we wanted, right? I can also quickly now create a plot here that shows this. And that's basically now the way for me to actually modify the data, right? So yes, at the heart, synthetic data will recreate the original data as close as possible. However, if I have some use cases where actually I want to modify the data, something like this, for example, where I want to change certain distributions of variables, I can do that. The cool thing is, yes, I did define age, if you recall, to 35. I defined that, and I also defined here the split between females and males. But everything else then was created synthetically so that all the correlations between those variables were still intact, which means I'm kind of like simulating the world. I'm like simulating like what would the US population look like if everyone was 35 years old and a 50-50 split between male and female. So you can really think of this also as a way to like simulate different scenarios. So some other things here that I will show is setting temperature and top P. So that's one of the advanced functions when actually creating synthetic data. You maybe notice from large language models, it kind of like defines how creative or how conservatively the data should be created. Let's start here with 0.9 and 0.9, creating here a, again, synthetic data set. That will give us a fairly good representative data. And we'll see this here in a second. We are now using this here to visualize that data. So here we have the original data in the black line and then the synthetic in the green line. So we see it's like, yeah, it kind of like matches relatively closely. It's not super close, but it's relatively close. If I want to do this again now here, and we reduce here the sampling temperature to 0.3, let's see what that does. So this will run here again. It's going to take a couple of seconds. That's now done. And so let's plot again. And so what we see now here is that we see many, many more individuals between 20 and 40. So basically what I did is, I reduced kind of like the variance in the data set. I more conservatively, kind of like the John Doe's, the average kind of like individuals, and I reduced diversity in my synthetic data set. If I increase temperature, if I actually were to do the other way around, I would see more diversity in my data set. It's another way of how I can actually control synthetic data generation, and a pretty cool thing. That's really at the heart what I wanted to show today. There's, of course, many more things. Maybe one more thing here. Once I have trained such a generator, I can actually export this. It's a zip archive where, again, you have the model weights in there. You have some of the metadata, everything that was learned during the encoding phase and things like this. And I can take this and I can go also to the MostAI platform. That's a service we're hosting here, also for free. You can set up for an account there. You can upload your generator. And here import a trained generator, and then you can take it from there. That's I didn't see it here. Anyway, you can take it there, and then you can actually do everything that you could do on the SDK also here with the UI, because the SDK again, that's the open source package that we have. It's all Python based. If you're more of a UI-based person, if you want to have an UI, you can also use our platform for free to basically do the same things. But that's it. Yeah, quick run through of the SDK.
Yeah, thank you. I was just curious, where does the name come from? Why it's mostly AI?
Yeah, so we've been around as a company for 8 years already, so well before the big AI hype. But yes, we've been using generative models, machine learning, AI certainly for many, many years. The reason is that, yes, we try to automate as much as possible, right? We try to use AI as much as possible in the generation, making it very simple to create synthetic data. But there's always a human in the loop, right? So that it's mostly AI, but there's a little bit of the human element still in there, and that's probably going to be there for quite some time. So that's why it's mostly AI.
Okay, makes sense. What are the main use cases? So the one we talked right now, we discussed is privacy protection, but I assume there are other use cases. What are those?
Yeah, so I would say that the main use case is really around privacy, as we discussed, right? So making data accessible, especially in large enterprise organizations where there's strict regulations. When you have GDPR and the privacy regulations that are applied. The other use case, and I demoed it quickly or briefly today, was anything where you need to actually modify the data. So one example there is if you have, for example, highly imbalanced data sets, fraud, for example, you have let's say, I don't know, credit card transactions, and you have millions of credit card transactions, but very few fraud transactions actually. You can use synthetic data in such instances to actually upsample the minority class and create artificially more fraud cases, and that can help downstream models. It's not a silver bullet. I don't like to oversell this feature, but depending on your use cases, it certainly can help. And it can also help with just explainability of models, things like this, creating data in order to show how models behave and all of that. So just think of it as a flexible tool that you have in your toolbox, in your toolkit to actually create data for your needs.
Amazing. And internally, you say you have some sort of model. Was it tabular ergen, or it's some sort of an LLM, right? Or what do you use?
Correct. No, so yeah, so it's tabular argon. That's what the model is called. It is also open source. We also released a scientific paper beginning of this year that explains the model architecture. It's an autoaggressive model, highly optimized for tabular data, and it's not pre-trained, right? So the model uses always the input data to learn everything from scratch.
Okay. And how many people are working on this project?
Well, so we as a company, we're about 35 people. There are, on the engineering side, probably about 20 people or so that are contributing to the repo at this point in time.
Okay. And do you accept the external contributions?
We do, yeah. And I think we already have one or two external contributors. But yes, certainly we would love people to get involved. There is a quick start guide also how best to contribute. There are discussions on GitHub and all of that. How you can also provide feedback. We always love feedback from the community. But yes, definitely open for external contributors.
Somebody wants to contribute. What's the best way of doing that? Should they pick an issue in your GitHub repository? Should they maybe join your community and ask what's the best way to help? Like, what's the, let's say, what's the happy path for people who really want to contribute and want their pull requests accepted at the end?
Yeah, so we have some contribution guidelines that I would recommend then reading in terms of actually creating pull requests. Probably as a best start first is to join the discussions on GitHub. We don't currently have like a Discord or a Slack or something like that. Everything's happening on GitHub. But yeah, joining the community there, joining the discussions, and then reading through the contribution guidelines before actually creating a PR is probably the best idea.
How old is this particular project? You said the company has been around for quite some time, but this particular project, for how long?
Yeah, so this again was released in January this year, end of January, so it's been around for 3 months. The company exists for 8 years already, and a lot of course, the everything that's in there, a lot of the IP and everything went into that SDK.
Yeah. So it's been three months old. What are your plans for the next quarter?
So good question. We are constantly expanding kind of like the capabilities, improving things that are possible. For example, I didn't show that today. I was like, we can also support language, so you can create synthetic text, and there are different ways of actually how you can use the SDK for that. We're going also in the next weeks and months. What we will introduce is the capability to create mock synthetic data. So today I showed that you have some existing data and you create a synthetic version of it. In the future, it's going to be possible to actually say, hey, I just want some data, some dummy data, some demo data, and then you can use the SDK to actually create that out of nothing using the power of pre-trained LLMs. So that's also coming in the future.
Oh, that's nice. And
for like testing and demo use cases, not for data science, but for software development.
Last question I like to ask everyone is, do you have any advice to anyone who is watching this?
Try it out. Synthetic data has been around for a couple of years now. So this machine learning generated synthetic data, it's still relatively nascent though, right? It's kind of like a little bit of a niche. And so people maybe have some I don't know, concerns or fears or questions around, just try it out, give it a try. It's actually super easy. It's actually quite cool to see how well it works, right? The quality that you get, the privacy guarantees that you get, and all of that. So yeah, just give it a try.
Yeah, I guess what it takes is have a good proper validation data set and then just try this thing. And I imagine, so in my head, when I was watching your demo, it was, okay, I have an original data set, then I train a model, I generate a similar data set. And in my mind, if I train a model on the original data set, if I train the same model on the generated data set, the accuracy should be more or less the same. So this is a simple test to do, right?
Exactly. So also what I showed with the QA, right, that gives you a first indication. What we always recommend people that are really like starting to dig deeper is what you described. So we call it TSTR, train synthetic test real. You train a model on the original data, you create synthetic data, you train a model on synthetic data, and then you compare the performance of the models on a holdout data set. And what you will see is that it's very comparable, right? It's not 100%, right? Because there is some data transformation that's happening, but it is very, very similar. And so, yeah, it's a great way to really then assess for your specific tasks, for your specific data and downstream tasks, the quality of synthetic data.
Hey, thank you, Tobias. Amazing demo. Thanks for doing this in open source. Thanks for making it available for everyone to use for free. So thanks a lot. Great demo. And yeah, thanks a lot.
Thanks for having me. Bye.